Good day everybody. Today we'll talk about relays. So why would we need a relay? Now let's say I want to switch something like this on with my Arduino board. Obviously I cannot do it with the limited current available from my USB port or directly from my Arduino. And it may also be that I want to switch say a 240 volt AC supply, or maybe something of a different DC voltage, so we will use a relay. So I think the first thing that we must do is look at the symbol for relay. So here we can see the symbol for relay, and you will see there's a coil there. Then there's a magnetic coupling to the switch. Now that's what a relay in its simplest form is a basic switch. So if we energize this coil, if we put electrical energy through this coil, a magnetic field will be generated and we will turn the switch in the other direction. In this case we've got a normally closed and a normally open connection. So if I energize the coil, the magnetic field will switch this little switch in a different direction and we will get contact. Alright, let's have a look at another symbol for a relay. In this case it's just a single switch. It's in a normally open position. If I energize this coil, then it will close the switch. So that's a very basic relay. Again, we will use it if we want with a low current switch a higher current. A relay will typically look something like this, and you will get different coils in those relays. The coils will either be 5, 12, 24 or whatever voltage that coil is designed for, and on the other side you will get one or more switches that will either be normally open, normally closed, and so on. So there's different configurations. Now if we use a relay like this, we need to add some circuitry to get it working, and let's have a look at that. This is a typical circuit that you will use with the Arduino if you've got a relay that's not already in a module. So here we've got our relay, that's our relay. Then we've got the switch of the relay that will typically connect our high current device of whatever voltage is required there. Then on this side, this is a 12 volt relay, so we will have a 12 volt VCC, and we will switch it with this transistor, 2N transistor, and then of course it will be coupled via current limiting to our Arduino output. So the Arduino output will switch the transistor and the transistor will switch the relay. I don't want to go into detail with the flyback diode that's situated here, but the reason for the flyback diode is if you energize this coil and if you then stop the electrical energy, it will flow for a short time period in the reverse direction, and that may harm your electronics. So the flyback diode, as you can see here, is coupled as reverse biased. So the positive comes to the cathode, which is not normally how you would couple a diode, but in this case you want to short circuit the EMF that's generated when this relay is switched off. So it will energize via the transistor, and then when the transistor switches off, the reverse current will flow, and that current will be short circuited by this diode. So that's a very basic explanation of the flyback diode. Now with the Arduino we will have many different types of relay boards that we can use, and I can show you here. Here's a relay board that's got 2 relays in it. So here's the switching side of that relay, where it will actually switch our high current load, and on this side we will couple our Arduino. Here's a different one. You can see this one's got 8 different relays. You've got place where you can select that 8 relays via your digital output of your Arduino. You've got VCC and ground. You've also got a LED indication for this board. Let me show you some other boards as well. Now these relays are rated for a specific current, and in this case it's rated, this one, 10 amps 240 volt AC or 10 amps 30 volt DC. That's the maximum current voltage that this relay's contacts will be able to handle. Now if you want to switch higher current devices, you need a different relay. This is also a relay board already configured, so it's got already the circuitry for the Arduino board on it. So again, you'll couple your VCC and your ground, and your signal will then switch this relay. But this relay has got a different current rating, and it can handle 30 amps instead of 10 amps. So 30 amp 220 volt, the specific relay will work. You can also see at the back, it's got heavy duty contact circuits towards the contacts, which can handle then a higher current. You can also see it's got a much better type of connection here on the high current side. Alright, so you get different types of these relays. I just want to show you something else concerning relays. You also get solid state relays. Now the difference between a normal relay like this one and the solid state one is this one's got physical contacts where the contact will open and close. And I've cut open one of these relays to just show you that. And there you can see the coil that's energized, and it will then pull that magnetic part towards it, and it will open or close this normally open, normally close switch here on the side. So this is basically the inside of a relay, a normal relay with contacts. Now if we move towards a solid state relay, they look like this. And this is a solid state relay. It does not contain any physical contacts. So obviously it will last much longer because there's no mechanical movement in that. You can also switch relays like this quicker. And another advantage of them is you need a smaller current to basically activate that switch. Well, these solid state relays you can use to switch AC supply but not DC. So they are mainly used to switch AC. So you've got your DC input on this side, and you can switch a AC load on that side. Right, let me show you another type of solid state relay. This solid state relay, you can see, is a heavy duty one, 100 amps. So the AC voltage on this side that can be switched is from 24 to 380 volt AC, alternating current. Your input DC voltage on this side to initiate this switch is between 3 and 32 volt DC. So that is this is then a heavy duty solid state relay that you can use to switch AC loads. Alright, I want to move towards the Arduino and the Arduino program. So I'm going to show you the basic sketch that I'm going to use to switch a simple relay board for the Arduino. But before that, I just want to show you the circuit that in many cases use on that board. And it looks a bit different than the one that we've displayed previously. And just select it there. There you can see that circuit. Now this circuit also includes a LED. The transistor and the resistors are already built onto the board, and also the flyback diode. So it's basically a module that already contains all of these components, and you can use just as it is there. You also get some of these boards where they've got an opto isolator between your Arduino switch and your relay. But in this case, no optical isolation there. So from your Arduino, you'll get a pulse. You will see that on your LED. Your transistor will switch, and you will in that way switch the heavy load on the other side. So that's it. So let's move to a basic program, Arduino program, and let me just move that a little bit. Alright, so this little program is just going to switch on the relay board on and off every 1 second. Let's have a look at the program. You've got your relay pin defined as digital IO7, and then in your setup I just say that the pin mode, that same pin, relay pin, is an output because we're going to write high or low to it. Then in our main loop, digital write, again the relay pin, which is pin number 7, low, wait for 1 second delay, then write the high to it. So that's our basic sketch, and let's quickly build our little configuration here. So here I'm going to use a 4 relay board, but I'm going to only switch one of the relays. So let's do our connections first. So we'll take from our 5 volt to our VCC there. We will then take from our ground to our ground of our board, and we set that our digital IO7 is that one there, digital IO7, make sure of that. And let's switch channel 2. So I'm going to put that towards channel 2. So that's how easy it is to use these boards, because they've already got their transistors, they've already got their flyback diode, they've already got the LED indication of that. Alright, so what you can do then is just compile and upload your sketch. So remember that sketch of ours will switch on the relay on and off every 1 second. So the relays, the sketch is already on the board, and you can see there that LED indicates that relay number, that's 1, 2, relay number 2 is switching. If I touch it, I can feel that it's switching. And if I take a multimeter and put that to continuity, I can go and on there on relay 2, you can see the multimeter is also showing that that contact is opening and closing between those 2 points. All right. So I hope you've learned something. Relays are handy devices in your toolbox, and they are easy to use with your Arduino microprocessor. There's many different types. You choose the relay depending on the type of load that you want to switch, how fast you want to switch, and how durable you want that to be. I hope this video helped each one of you, and thank you for watching. Thank you. Bye-bye.